Good morning, ladies and gentlemen. I just thought this morning I must just record some initial ideas, just off the cuff ideas regarding how it is actually possible to talk about the learning of mathematics in a way that actually excites the mind, excites the student, but also in ways that we can draw direct relationships between the actual study of mathematics and the life that we live. Let us all first remember that we live in a three-dimensional world. We experience life in a three-dimensional way. So that's the universe we all occupy. So the challenge with most students that they encounter and their parents and teachers is that maths is students would often ask, why am I studying mathematics anyway? And I think they are not alone in that. I think there are also grown-ups, post-school people, grown-ups who think that such questions obviously are justified. They would wonder why did they spend all the trauma and all the years being forced to study mathematics. And the problem there is actually not mathematics itself. The problem is us, human beings, in the sense of your parents, your teachers, and your educational managers. I think these three people combined, they fail to actually resonate or bring the relevance, bring across the minds and the eye of the student the hidden insights of mathematics, how mathematics actually plays a role in our daily lives. It is not just enough to say study maths because it's good for your future. I think we need to cross the bridge and actually demonstrate in real terms, in physical terms, how real life actually connects with mathematics, how it works, how it applies in the workplace, how it influences productivity positively, how it influences human progress, how it influences the technology. In fact, mathematics itself is a technology. So when people talk about technology, we should rather be saying mathematics, because many of the useful tools that make our lives easier are tech objects. And these tech objects are driven at the heart of them by mathematics. So I think we need to carry on and try and get better at communicating mathematics and try and draw a picture and show students what role it plays in our lives on a daily basis. The innovations, the science, the tech jobs, the tech products, how these products actually make a difference in our lives and makes our lives a little better. So what I'd like today is just to talk about, for example, what do I mean when I say we live in a 3D world, and how mathematics plays a role in that. In my hand, I've got a box. You can take a shoe box, you can take any form of box. This box has got volume inside. If I open the lid, the box has got volume, and you can put objects in it. You can store your shoes, you can store anything that's important, anything, you can just, whatever it is, an object, you can put it inside this box. But if you notice, if I didn't tell you this was a box, I just said, you've got length going down, height going down, and you've got width going across. So if you knew what numbers these were, whether this was 3 meters or this was 5 meters, 3 centimeters, 5 centimeters, whatever the case is, if you knew those numbers, you can take them and multiply them together. And then if you did that, if this was 3 meters and this was 5, you multiply 3 by 5 and you get a 15. So what does that 15 mean? So in this case, it will tell you about the area, the inside area, the space in between. The 15 would represent this area here, the area of this object I have in my mind, in my hand. So this is just a simple multiplication of dimensions, the upward, up and down dimension and the across dimension. So that gives you area of this shape, this entire shape. You get an area of it. So we now learn that by multiplying 2 dimensions up and across, you get to know, you get to learn or figure out what the area is of this object. And in young students in late primary and also even in high school, they battle with these concepts, a concept like this, for example, because all they learn is just formula that you take a number and multiply with the other. They don't really know what it actually means. That in the stuff that you encounter on a daily basis, this dimension and that dimension, if you multiply them together, whether you knew the number or you didn't, but if you, the act of multiplying them together, you get to learn about the area in between. And you can do this on a flat piece of paper, for example, in your desk or in your table or wherever with a piece of paper. You can draw that. You draw a two-dimensional object. So that in its own is a mathematical object. But also the connection with this area I've just shown is, for example, because we call this a square, right? Okay, these angles may not be the same, but let's just say the sides, because this side is longer than this side. But let's pretend that they were. It will still apply. Let's just, okay, this is a rectangle, but let's just pretend that this was a square and it had 4 equal sides. And what is the act of squaring something? So the act of squaring something, again, is taking something, an object, and multiplying itself 2 times. Then you are squaring something. I've just asked that we pretend this was a square. So those 2 things are related as well. The fact that you've got 1 dimension multiplied by another dimension, you get to learn about the area of a square. But another idea that is connected to that is taking an object or something and multiply by itself 2 times. You've squared it. So geometrically, again, pretend this was a square. This is what squaring means. If you pretend this was a square, this is what the act of squaring actually means. The act of taking an object and multiplying it by itself, like a to the power 2. That's a times a. A multiplied by itself 2 times. That is a square. You've squared it. Those 2 things are connected, and they are related. They are connected to each other mathematically. And now let's move from the act of squaring, and upgrade our understanding to a next level, which is a cube. Again, I'm going to bring back this box. Now, this box obviously has got various sides, and now because it's now a cube, we've actually done something to it. Remember initially when we started with a 2D two-dimensional object, we said this length multiplied by this length gives us an area. Now, because of course we've got this side and we've got this side as well now on a 3D object. This is now a 3-dimensional object because it's a box. Yeah, it's a 3D object. So what's the difference between a 2D and a 3D? A 3D, if you know how to figure out an area by multiplying 2 dimensions, doing 3D is not very different. You just add a 3rd dimension. In other words, you start where you started with this dimension, multiply by this dimension. The next thing you just have to do is to, after having done that, you drag this face, assume you can drag this face and drag it across the box to this other side. So you end up having two sides, this front side and the back side. So you've merely taken this face and then you dragged it across to this side. So you still have the up and the down, that KV area, and then you add the fact that you have dragged it across to create another face this side. Is now you've got two sides. So the act of dragging the same face that you used to find the area, you dragged it across, now creating two faces. You take the two-dimensional sides, the 3 and the 5, and then you multiply it by the third, the fact that you have dragged that face across. If let's say this was 10, you just multiply it by 10. So you'd have 3 times 5 times 10. So the number you get out of that, you get the volume of a three-dimensional object. So now a 3D object will now give you volume. That's how we work out volume, that you can store things and put it inside, because an object that is three-dimensional does no longer gives you area now. It gives you volume. So again, connected to what kids study on a daily basis. Sorry, what they study at school and we meet on a daily basis. So a volume is a 3D shape, right? So B raised to the power 3, we say we've cubed it. It's a cubic shape. So because it's got 3 dimensions, it takes into account the 3 dimensions. So squaring, cubing an object is not a random act. It's B times B times B 3 times. The same object multiplied by itself 3 times. So that means you've cubed something. So a cubic object gives you, like geometrically or visually in your hand, it gives you a volume. So that's actually very important in terms of conceptualization, understanding concepts from the abstract, the B to the power 2 or B to the power 3. Understanding that when you figure that out, it's not just about an act of using a calculator or just memorizing, but it's actually physical. You can illustrate it geometrically and give a 3-dimensional look at it. So ladies and gentlemen, I'm going to end there, but I'm going to continue because there's more to talk about here. I'm going to continue and add a few more ideas later on. Thank you for your time. Have a good day.